So for my experiment, I decided to make and melt pineapple popsicles. The materials I used were a popsicle mold and pineapple juice, as well as a freezer and a bowl. So for the first part of the experiment, I poured the juice into the mold and then stuck that into the freezer overnight. The next morning, I took it out. As you can see, it is now a solid. One factor that identifies that it is a solid is that it stays in one shape. The freezing made it a solid. This state change can be explained by the third and fourth laws of the kinetic molecular theory, which state that the particles are always moving. Their freedom to move depends on their state, and that these particles move because of energy, and the amount of energy that they have determines how much or how far they move. In the liquid state, particles move relatively quickly because they have a relatively large amount of energy inside of them. And as the ice pop got frozen, the heat energy that was in the liquid left, and the particles were forced to slow down, resulting in a solid, as you can see. This change is not considered a chemical change, because although the particles slow down and the juice looks different, it has the same chemical makeup as it did before, and I can easily return it to its former state, as you will see me do. So next, I left the ice pop in a bowl unattended. A family member who will remain unnamed then saw my phone and gave it back to me after deleting the time lapse of it melting to get back at me for not putting on a movie last night. So you'll have to watch these images I made of an ice cube melting instead. Basically, what is happening is that the pop is slowly gaining more and more energy from the room temperature air, and its particles are beginning to move faster and faster. Now, as you can sort of see, it reaches a point where some of it has returned to its original liquid state. This is the ice pop's melting point. At some point in time, the pop turns fully liquid. This is me using a spoon to illustrate that. It's the heat of its heat of fusion is the temperature required to melt a certain amount of the substance. Because I don't own a normal thermometer, I used a very old one intended for babies, and it told me that it was running a fever, which I highly doubt. So, according to an article by the Florida Department of Citrus, because yes, that is a real thing, the heat of fusion of most citrus juices is approximately equal to about 30 to 40 degrees Celsius. Again, just because the ice pop looks different does not mean that any chemical change has occurred. All that happened was that the particles sped up and it turned into a liquid, which can be explained by the fourth law of the kinetic molecular theory as stated earlier. So no change occurred to the chemical makeup. Because it is a liquid, the juice conforms to the shape of the container and the particles move more freely. As you can see, if it were a solid, it would not be able to fit into the shape of the inside of the spoon or the bowl very easily.